Hey everyone! Today we're going to take everything that we've been learning this entire week and we are going to combine it because we learned about these individual things in order to work with them all together. We did this last year in chemistry, but let's go ahead and bring this back because it's going to be an important concept. We have the mole, mass, and representative particles. As a review, in order to convert between mole and mass of something, so remember mass is generally given in grams, we have to use something called molar mass. The relationship is that molar mass is always going to be equal to 1 mole. So again, molar mass is always equal to 1 mole. The other relationship we have to think about is the moles and number of particles. So remember that 1 mole of any substance is always going to be equal to 6.02 times 10 to the 23rd representative particles. Representative particles can be one of 4 things. Remember, it can be atoms if we're talking about an element. It can be molecules if we're talking about a molecular compound, which is going to be nonmetals and metalloids. It can be formula units if we're talking about an ionic compound, and these are going to have metals and polyatomic ions. And the last one, ions, for anything that has a charge in it, so such as calcium 2 plus or K plus or F minus. Here is an image last year you guys were given in chemistry to help you kind of see the relationships of how to move between mass, mole, and representative particles. One thing to always remember is that mole is your middleman. It provides a bridge between all of these concepts that we've been learning. It is the center and it's the most important. I also really like this picture because it helps you visualize. If you're giving grams, in order to cancel mass, you have to put it on the bottom and you put mole on top whenever you're going that way. But if you're going to mole to mass, to cancel moles, it goes on the bottom, molar mass on top. Same thing over here. If I'm going from moles to represent particles, it's going to show me my conversion right here. Now, I had a lot of you guys ask me in class, are you guys going to be able to use that on your test this year? And the answer is no. We covered this last year, and this is an advanced class, so we need to take one step further and help bridge ourselves and build up from what we learned last year. One thing to always keep in mind is that your units have to cancel. So always ask yourself, what are you trying to get rid of, and how do I do that? So let's go ahead and do our first example. Here we are going from representative particles over to our mass in grams. Whenever you're given a problem, the first thing that I always like to do is that my unit that I'm using matches up to whatever substance that I'm working with. Here I have a compound because it's 2 or more elements. I have hydrogen, which is a nonmetal, and oxygen, which is also a nonmetal. So 2 nonmetals is going to be a molecular compound. So molecular compounds always get the unit molecules. And you're going to see, yes, this does match up. Then, now that I know that it matches up, we can go ahead and get started. With any conversion, always start with what you're given. So I'm given 7.84 times 10 to the 24th molecules. You ask yourself, how do I cancel molecules? And most of you guys know to put it on the bottom. And remember, your middleman is always going to be moles. Here, the relationship between molecules and moles, hopefully remember 1 mole is always equal to Avogadro's number, which is that 6.02 times 10 to the 23rd. So here I've canceled my molecules. So you're left with moles. And you have to ask yourself, is that what I was trying to get in the end? Here, this is going to show you that no, you were not trying to get that. You're trying to get mass. So I have to keep going. So if I have moles up here, if I'm trying to get rid of it, moles is going to go on the bottom. And here I'm trying to get to grams, so I can put grams on top. And you ask yourself, do I know a relationship between grams and moles? And you do. That is molar mass. So if you calculate the molar mass of H2O, it will be 18.0148 for every 1 mole. Then you can go ahead and cancel your units, moles, and you're left with grams. Ask yourself, is that what I was trying to find? If your answer is yes, you don't have to go any further. You can stop and go ahead and calculate this. Remember, if it's on the bottom, you divide, on the top, you multiply. When you go and solve this, you get 234.611 grams. But again, we have to worry about sig figs. Here this has 3 sig figs, so my answer can only have 3. So 235, because that 6 rounds up that 4, grams of H2O. So now let's have you guys try this. Let's see how you guys did. Hopefully, the first thing that you did was you looked at this compound. We know it's a compound because it has 2 elements in it. And notice that calcium is a metal, which makes this an ionic compound. So you have to see, does your formula units mean ionic? Yes, this is good. So then you can go ahead and solve by starting with what you know. In order to cancel formula units, hopefully you put it on the bottom with moles on top. Remember, moles is your middleman. The relationship is always 1 times 6.02 times 10 to the 23rd. Once you canceled out formula units, you are given moles, and hopefully you notice that moles is not what you're trying to get to. You're trying to get to mass, so you have to keep going. To cancel moles on the bottom, and then mass on top. Here, if you find the molar mass of calcium bromide, you're going to find it to be 199.886 for every 1 mole. Here, you cancel your mole units, and you are left with grams. And yes, that's what you're trying to find. So you can go ahead and equal this out, and you get 1,175.409. Again, sig figs, here you have 3. So this answer can only go to 3, 1, 1. This 5 rounds up that 7 to an 8. But 118 is not the same as 1,175. So I add that 0 to keep the same place value. No decimal, or that would make it significant, grams of CaBr2. So how did you guys do? Let's try to go the opposite way. Here we're going from mass to representative particles. Again, the first thing you should ask yourself is, does my label match up with what I have? Here I have a compound. We have carbon, hydrogen, oxygen, and you should hopefully recall those are all non-metals because they're to the right of the periodic table except for hydrogen, which is still a non-metal. So it should have the unit molecules, and it does, so it's good. Then you can go ahead and solve. You are given 5.23 grams, and you need to ask yourself, how do I get rid of grams? And the answer is to put it on the bottom. Now remember, grams, the only stepping stone you can go to is moles. Moles has to be your middleman always. Always, always, always. So moles. So for every 1 mole, glucose has the molar mass of 180.1548. So I've canceled out my grams. Next thing that you need to do is to cancel your moles, because hopefully you asked yourself, is moles what I was trying to get to? And the answer would be no. You were trying to get to molecules. So moles on bottom, molecules on top. So for every 1 mole, there are 6.02 times 10 to the 23rd molecules. Then you can go ahead and solve this, and you'll get 1.7476 times 10 to the 22nd. I'm only allowed 3 sig figs, so 1.75 times 10 to the 22nd molecules of C6H12O6. So now it's your turn to try it yourself. Let's see how you did. Hopefully, again, the first thing you checked is if your unit matched up. Here you're given iron. Iron is a lone element by itself, so yes, it should get the unit atoms. That's great. That's awesome. So you all start with what you know, 13.12 grams of iron. Notice that you're trying to cancel grams, so hopefully you put that on the bottom, and you know your middleman should always be moles. So for every 1 mole, iron weighs 55.845 grams. Cancel my grams, and I'm left with moles. You should have asked yourself, is moles what I was trying to find? And the answer would be no. You're trying to find atoms, so you have to go ahead and keep going. So you keep going. So for every 1 mole, because moles what you're trying to cancel, there are 6.02 times 10 to the 23rd atoms. And then here, this is what you were trying to find, so you don't have to keep going, and you can go ahead and solve this out. Hopefully you guys got 1.414346 times 10 to the 23rd. If you're rounding to the correct number of sig figs, this is actually allowed 4 sig figs, so 1.414 times 10 to the 23rd atoms of Fe. So how did you guys do? Oops. 1. There we go. Now, one thing I'm going to be very specific on is make sure that the number of particles matches. Every problem that we've been doing, I tell you to check your unit and make sure that it matches up. For example, if you were going to go do this problem, our substance is NaCl. This is a compound because there's 2 elements in there. And you're going to notice that Na is a metal. So this is actually an ionic compound. So this should get the unit, formula unit, but instead it got atoms. This tells you that there's going to be an extra step involved. So let's go ahead and solve it, and I'll show you where that extra step gets added in. Here you start with what you know, 5.64 grams. Again, you want to cancel grams, so it goes on bottom. Moles is still always going to be your stepping stone. So for every 1 mole of salt, there is going to be 58.443 grams. So go ahead and cancel grams. The next thing you say, well, I have moles right now. That's not what I'm trying to find. I'm trying to get to atoms. So here I have 1 mole. But notice, this is where that step gets tricky. For every 1 mole of salt, you have a formula unit. So you have 6.02 times 10 to the 23rd. So again, notice that here we have to go to formula unit first. From there, this is where your extra step comes in. If I want to cancel formula unit, it goes on bottom, and I can eventually get to atoms on top. So you have to count how many atoms are in 1 formula unit. Here there's 1 atom of sodium, 1 atom of chloride, so there are 2 atoms total. So you canceled out grams, you canceled out moles, you canceled out formula units, and you've gotten to your atoms. So you can go ahead and solve this across. When you do this, you get 1.161911 times 10 to the 23rd. You can go to 3 sig figs, so 1.16 times 10 to the 23rd atoms in NaCl. Here, I want you to try this one yourself. Let's see how you guys did. So again, the first thing you should do is always make sure your units match. Here I have H2O2. This is a compound because there's multiple elements in it. Hydrogen and oxygen are both nonmetals. So then you have to ask yourself, well, nonmetals tells me that this is a molecular compound. So this should get the unit molecules. But it doesn't. It gets atoms. So we know right then and there that there should be an extra step. So we always start conversions with what we know, 6.11 grams. Then what we do if we want to cancel grams, it's got to go on the bottom. Mole. Mole is always, always, always your stepping stone. For every 1 mole of H2O2, it weighs 34.0138 grams. Then we've canceled grams. If we want to cancel moles, it goes opposite. Now here's where people get stuck. Remember, we're working with H2O2. So this means molecules have to go on top when we're talking about moles. So every 1 mole, there are 6.02 times 10 to the 23rd molecules. Here I've canceled out moles. Molecules is not what you're trying to get to. You're trying to get to atoms. So that tells you that you need another step. So to cancel molecules, it goes on the bottom, and atoms goes on top. So for 1 molecule, there are how many atoms? We have to go ahead and count. So there are 2 hydrogen atoms plus 2 oxygen atoms. Gives me a total of 4 atoms. You've canceled out molecules now, and you can go ahead and solve. When you do that, you get 4.32556 times 10 to the 23rd. And when you round this to the correct number of sig figs, you get 4.33 times 10 to the 23rd atoms in H2O2. So how did you guys do? If you guys struggled on this, make sure that you keep note and you let me know. I can give more practice problems. You also are going to have this on your homework. If you struggle on your homework, star those problems. We could work on them when I get back to school in the next class period. One thing to really stress, pay attention to these videos, go back through the problems, and make sure that you're canceling your units. If you still struggle, make sure that you guys come in for help. And otherwise that's all I got for you today, and I hope you guys have a great day.